Hello, today I would like to talk about LFT testing and false positives on the related field, which is Bayesian probability. And you can trust me, I'm a physicist. So there have been, about this false positive, there's been quite a lot of confusing statements in press and media. And these statements make people unsure about the tests. And very often it is also related to Bayesian probability. And the people that talk about it, I think they may not always know exactly how it works. And what it makes it even worse is that, in my opinion, Bayesian probability is one of the worst explained topics ever. And I will try my best to explain it in the most simple way, or at least in the most understandable. Okay, two things that always come up which are important in a test is sensitivity, which is the same as the detection rate. It tells you if you have the virus, if you have an illness, how good is the test to detect the illness. And for the LFT test, it seems to be around 70%. There's a specificity, which is if the test tells you that you have the virus, what is your chance now that you do actually have it, so that it doesn't tell you you have it or you don't have it. And this seems to be greater 99%. So this sounds very, very high, but as you will see, it has still a very, very dramatic effect. Okay, Bayesian probability. I want to quickly cover this. One is it is a conditional probability, and as said already, it's very counterintuitive, and there are no good explanations around. Now, I quickly want to explain this formula, because if you are one of the people who clicked on this and want to know about Bayesian probability, so this basically means that what is the probability that B happens, given A, so that an event A has happened, and what's your probability that B will happen? Or in terms of this LFT test, now, this means what is your probability that you have the virus, given that your test tells you you do have the virus. So what is the actual probability that if your test tells you have the virus, what is your probability that you really do have it? Now ask yourself this question. That's the big question. The LFT detection is about 70%. You just tested positive. What is the chance? What do you think is the chance that you have the virus? I give you a couple of seconds. Okay, your guess was probably 70%, but it is not 70%. And this is where the confusion comes in. And it can, in fact, it can be lots of different percentages depending on the situations. And I will now explain on a couple of different examples leading to the LFT test how this works. Okay. Now, let's go to the first very simple example. Let's say you have a test, and the test has a 90% detection. This means 90 out of 100 tests will tell you that you are ill when you are ill. And you have the false positive. So when the test tells you are ill, actually 5% of the time that's not true. 5 out of 100 tests will tell you that you are ill when you're not ill. And the third parameter, or the third important factor in all this is how many people are actually ill in the population. Let's assume 10% of the people are ill. So 10 out of 100 are actually ill. Now, you test positive. The question is now, what is your percentage that you are actually ill when you have tested positive for this illness? Okay, I just used 1,000 people to make the calculation easy. So the people with illness in this 1,000, we said is 10%, so it's 100. Then the people with no illness is the rest, so 900. 1,000 minus 100. The positive tests, so the ones that have tested positive and are ill is 90, because it is 90%. So out of this 100, 90% they will test positive and they will be ill. But then you have another 45, which is this 5% out of this 900. This 5%, they also all test, and out of these 900, but they are not ill, out of these 900, 5% of them, 45 So 45 of them, they will get the test result that they have the illness. So what is your probability in this scenario that if you do the test, that you actually have the illness? It is 90, which is the correct ones, because you could be one, out of 135. So your chance of being ill when your test says so in this particular circumstances would be 67%, 0.675. This is 90 divided by 135. Okay. Now, for the ones who are particularly interested in the Bayesian theorem, what it boils down to, the Bayesian probability is the correct positive divided by all positives. And how you get these all positives, this of course it can sometimes be the tricky thing. But the basic idea is that you have the correct positives divided by all. Okay, let's go to the next. Let's say you have now a lower false positive rate. Let's say your test is better. You have still a detection rate from 90%, so this stays the same, but the false positive are only 1%. So only 1% of the time when the test tells you are ill, you're actually not ill. So we leave the people ill in total 10%. You test positive. What's your percentage now? Now, this time I use 10,000 to make the calculation a little bit clearer. The people with illness now are 1,000, 90%. 10%. 9,000 are not ill. It's the other 90%. The positive, you have a positive test and the people are actually ill. Well, this is 90% of this 1,000 that have the illness because they have done the test and they say the test tells me it's ill and they are ill. But you have another 90, which is 1% out of this 9,000 that also get a positive test. So they also say you have the illness, but they don't have it. Now your probability now, so the total positive test is 990. So the probability now is 900 out of 990, or 0.91%. You can say, yeah, but I am ill or I'm not ill. Well, that's exactly the point, because you could be either one of the ones who is really ill, or one of the ones where the test tells you it is ill. And therefore, out of this thought that you could be either one or the other, because you could be one that is actually not ill, but the test tells you ill, or you are actually, this is where you get this probability. In this case, it's 0.91%. Now, about the 91%, the test, it gives you 91%, although the test only finds 90% detection rate. Now, what is actually, again, what it tells you, it is, okay, 90%, 9 out of 10, it finds the virus or the illness, but when it tells you, then you can, in this particular case, 91% sure that you do actually have. Okay, let's go less people in. Now, if I put 2% in for the people, I leave everything else the same. 10,000, I have the people with illness is gone down. I have only 200. People with no illness is 9,800. The ones that are correct, get a correct result, where the test tells me they are ill, and they are actually, it's 180. But the tests also 91% out of this 9,800, so 98. I also have the ones where the test says they have the illness, although they don't have the illness. So the total number now of positive tests is 278, but the correct ones are 180. So your chance of being ill is in this case 65%. By the way, the detection rate is often given the other way around, which can make it even more confusing. It's quite often called the false negative rate. And rather than telling you the detection is 90%, it tells you, the medical paper tells you, it has a false negative rate of 10%, rather than saying a detection rate of 90%. Okay. Let's go now. We have a lower detection. Let's say now that the actual detection rate of the illness is only 70%. So only 70 out of 100 tests will tell you that you're ill when you are ill. So the test only detects it 70% of the time. The rest stays the same. Now I have 1,000, 200 stays 10,000 again, 2% again, 9,200 is the 2%, 9,800 is the rest. The positive test and ill is now 140 because out of this 200, only 70%, so 140, the test will detect. But the test also gives me another 98 out of the one who are not ill. So my total positive test would be 238, and the correct ones over the total positive is now 140 over 238, and which is 0.59. So your chance of being ill in this particular case is 59%. Now, the detection rate is linked, so this shows you the detection rate because it has changed from the 65, is linked to your chance of being ill, and I think for once this is quite intuitive. Okay, now let's go to the actual COVID test. Now the COVID test we said is 70%. The false positive, this is what the government tells us, is greater 99%, but they don't really know by how much. But they know it's about 99% plus. Okay, now the thing is, how many people are actually ill? At the moment, we can assume that 25,000 people are ill because we know the actual infected people, and then there will be a number that haven't been detected, so or they don't have any symptoms, they haven't tested themselves. So let's assume it's 25,000, which is probably correct at the moment. Then what you have, so we have 66 million people in the UK. Now 25,000 would have the illness. People with no illness would be 65,000. So the positive test and ill now is 17,500. So this is 70% of this 25%. But I have another huge number, although the test is quite reliable. So only 1% when it tests you ill, it actually is not, you are not ill. You would still have a positive test of 659, 720. So the total positive test is 677. And if the probability that you are ill now is a meager 0.03, so only 3%. So at the moment, if you test one time, and the test tells you are ill, you only have a 3% chance that you are actually. So the 3% is very counterintuitive result. Okay. Now, okay, what should you do now? You test 2 times, because if you test 2 times, now the detection rate is 70% for the first time, for the first test, 70% for the next. So 0.49, you will detect this virus twice. The false positives will 1% of 1%, which is 0.01 times 0.01, which gives you this number, 1 out of 10,000. And the people ill in total stayed the same. What is your probability now? So all these numbers, see, the people with illness is 25,000, people with no illness, of course, the same. But the positive tests and ill, they would have gone down now to 12,250. The positive tests and not ill, however, the ratio of this is a lot less because the positive test is only 6,598. So the total positive tests now is 18,845. And your probability, the correct ones, which is the 12,250, over the total ones is 0.65. So the chance of being ill is 65%. So at this point in time, you have a 65% chance that you are actually ill if you do the test twice, the LFT test twice, and it tells you so. Now the other thing is you should definitely test 2 times. Now, you should also test 2 times to make sure that you don't have the virus, and see one of my previous video, because testing twice will increase your probability of detecting the virus. And again, the probability that you detect the virus is different from the probability that when the virus is detected by your test, you actually have the virus. These are 2 different things. And how this works with how you can increase your probability of detecting the virus is in the other video. And finally, in any case, when you detect the virus, get the PCR test, because this is the most reliable test available at this point in time. And last but not least, I want to refer to my earlier videos. Look under Physics COVID on YouTube, where I have several other videos, many of them about these topics, amongst them also the one why you should test twice in order to make sure that you don't have the virus. Bye for now.